Hello everyone, thank you for joining me today in this session. So today in this session we are going to begin this C project, which is the C preprocessor. In the beginning of this C programming, we talked about the C compilation process, right? Which we said it involves almost 4 phases, right? So it means for your program to be compiled, it has to follow those steps. So the first one we talked about was the preprocessor. We then talked about the compilation, the assembling, and also the linking, right? So these are all stages, or these are all process that your file needs to follow before it is being compiled. So today we are going to focus on one of these phases of compilation, which is the preprocessor. So we need to understand what this preprocessor is. So actually this preprocessor is a file, should I say a file or a code? Actually it's a code that does some work on your file before the file is being compiled by your compiler. So it's just like it reduces the workload for the compiler. Okay, so there are some things that the preprocessor does on your file before the compiler actually does its part. Okay, so that's why I said it reduces the workload for the compiler. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to b12learn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX complete C programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, small nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor because I've already registered. That's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. So now let's see something like this. Let me just create a test file. So all we've been doing is we've been doing something like this: hash include, normally main.h, and we used to do something like this as well: hash include stdio.h, right? We've been doing something like this. So all these things here, you are seeing this hash, you are seeing here. When the preprocessor sees this, it knows that, okay, it is responsible for handling such cases. So anything that begins with the hash key, right, with the hashtag here, it is considered a preprocessor directive. Do you get it? It is the role of the preprocessor to handle it. So the compiler is not going to do anything about this. Instead, the preprocessor will do it. So any line of code that begins with the hash character here is considered a what? A preprocessor directive. Do you get it? And we've explained what happened in this case when we're talking about the C compilation process. If you've not watched the video I made on hello world, please go and refer to the video. You understand what I'm trying to say here. So this hash include here will get all the prototypes in stdio.h, right? And it will paste it in your file, isn't it? So it will paste it in your file. So now your file will contain all the prototypes and also the code you wrote, right? So after including the prototypes here, the hash include will be removed, right? Because it has been dealt with already. That's the function of the hash include, so that it will get the all the prototypes in the header file in which you're defining. right? So today we are going to see what we can use these preprocessor directives to do as well. So let me delete this part here. All right, so if I have something like int main, if I should say void, right? I want to test something for you. So there are a lot of things we can use these preprocessor directives to do. Okay, so assuming I have a constant value in which I want to use throughout my program. Let's say the value of pi, right? The value of pi, which is 3.142, right? That's the value of pi. So let's say I want to be using pi throughout my program. As you all know, the value of pi is constant. It's not changing, right? So I want to use it throughout my program, right? So there is no need for me to be declaring a variable to hold it, because the variable will also take a space, right? Much space, in fact, since we are storing a floating value, right? So I can just define a macro which is going to hold that value. And this macro is a preprocessor directive. Okay, or let me say this macro is defined as a preprocessor directive. So all I need to do here, I can just say hash define. So it means I want to define what a macro, and this macro is simply just like a variable. Just take it as a variable, but it is not. Okay, it is just like a variable that holds the value in which you want to use in your program. So assuming pi, I will just say pi. And one thing you need to take note of is that these macros by convention are written in uppercase characters. Okay, they are written in what? Uppercase character. All the hash, if not define and define, hash and if we've been writing our main.h, if you can remember, we always write them in what? In uppercase. So they are also macros. Okay, so here I will pass in what? The value in which I want to store in pi here. So assuming 3.14, 3.142. So anywhere I call on pi in my program, it is going to print 3.142. So take note, you are not adding any semicolon at the end. This is a preprocessor directive. So here, let me try printing the value of pi. So if I should say printf, sorry, not in caps. So printf. So I'm printing a float. So I'll just say %f /n. So let me pass in the variable name, which is pi. Sorry, the macro name, right? So let's try compiling this. If I should say gcc test.c-o, let me call it t, right? All right, so let's run it. So did you see that I got 3.14? Why am I getting extra 3 zeros here? Because by default, when you use the %f, it's print what? In 6 decimal places. If you don't want it in 6 decimal places, then I can do something like this, 0.3. I want it in 3 decimal places, right? So let's try compiling this. So did you see that I got it in 3 decimal places printed? All right, so this is what I want to explain to you about the preprocessor directive. Okay, there are a lot of things we can use the preprocessor directive to do. So here we use the preprocessor directive to define a macro. So what is going to happen here before compilation is, the moment the preprocessor sees this, it knows that it is responsible for handling it. So it will look for wherever pi is placed on your program, right? It will look for it and it will replace it with the value 3.142. Do you get it? It will replace it with the value 3.142. So what is going to happen is just like something like this. If I should delete this, I just say 3.142 here, and then after that, then this particular part will be printed, because it has already included the macro and the value here. Do you get it? That's just what the preprocessor directive does. It just tells the preprocessor that you are the one responsible for handling my problem now, so please handle it. That's just it. Okay, so there are a lot of things we can use the preprocessor directive to do. So there are a lot of things we can do with this preprocessor directive. So what we've been doing inside our header files in the previous project we've been solving is simply adding our function prototypes, right? But the use of the header file does not stop there only. So this macro definition, they are mostly done inside the header file. Okay, so now we are going to see more about this preprocessor. Okay, so we can even write functions in our preprocessor, but we are going to see that when we begin solving examples. All right, so let's go on. Let me delete this file. It is not part of the program, right? So tests, then T here. All right, so let's begin task 1 of this project. I believe this is clear, right? My explanations are clear. Okay, we'll talk about it. If there is need for us to explain anything, we explain it before solving a problem. Alright, so here it says we should create a header file that defines a macro named size as an abbreviation for the token 1024. This is very simple. Let's just open the header file. I'll just say vi paste. So here I need to guide it, this header file. So what's the file name? Is object, right? Object like macro underscore h, right? I have this, isn't it? So here I need to say hash define, hash define, right? Paste this, yeah. So what again? Hash and if. All right, so I need to define the macro here, right? So how do we define macro? I've already explained that. I simply need to say hash what define, right? And then I'll pass in the macro name. In this case, it is what? Size. And then what's the value? 1024, isn't it? So no semicolon, nothing at the end. So let's exit this. So what I'm going to do here is let's copy the test file and let's see if the macro is going to work. So 0 main.c. Okay, I'm supposed to say vi0 main.c, right? So here I'll just paste this. So here I need to say hash I. All right, so let's compile the program. Copy, paste. So it has been compiled, right? So let's run the compiled file. So did you see that I got 1122? So this simply say 98 plus whatever is in size. And what do you have in size is 1024. So this is just like 98 plus 1024 and then the value is printed. That's just it. Okay, so now let's move on to the next task. This task here says we should create a header file that defines a macro named pi as an abbreviation for the token 3.14 something, right? So we've done something similar, right? So we are going to do it here again. So this is going to be vi paste the file name, yeah. So I need to guide it, right? If not there, file name is pi underscore h, then hash define, right? Hash define, then pi underscore h again, then hash and if, right? So here I can just say hash define. What is the macro name? Pi is the macro name, and also what? This is the value, right? So copy this and I'm going to paste here. All right. Okay, then what? Let's create the test file. So vi1 main.c, right? So paste. So here hash I. All right, so let's compile this and let's see. Copy and then paste. Good, so let's run it. So let's see it. So did you see that we got the exact value here? When you look at this, this is pi, right? So this macro here is holding what? This exact value here, right? So they declared a variable r already, which is of value 98. So this is just like saying pi times r times r. This is what? R square, right? Pi r square. So they are trying to find what? The area of a cycle, pi r square. Okay, that's just what they did here, and they are printing it in what? In 3 decimal places. That's why we're having 855 after the decimal point. Okay, so that's all. Don't forget, add, commit, and push to GitHub, and then run your checks. So let's move on to the next task. All right, so this task here says we should write a program that prints the name of the file in which, the name of the file it was compiled from, followed by a new line. So these macros here, there are actually some macros that have been defined already, right? These macros have been defined already, and they are called what? Predefined macros. Do you get it? They are called predefined macros. They have been defined already. Okay, they have been defined. So let's see some of these macros here. So if I say hash include stdio.h. So if I should say int main void, right? So here, assuming I want to print the current time, on my machine, right? So I can use a macro which is called the time. So printf, I'm printing time, so it's going to be a string %s /n. So I will now call the macro here. So to call the macro, you simply need to use underscore, then what again, then time. As you can see, I use double underscore before the time, and then close it with what, double underscore as well, right? So this is going to print the time for me. So let's see. So let's compile gcc -ot compile. So let's run it. So did you see that I got the exact time on my machine? It's because my screen is not recording up to that point, but that is the time currently on my machine. It's 9:30. Okay, 24 hours. Yeah, it's using the 24-hour clock. So that's what this macro does here. Okay, the time macro. So there is another macro as well. There are a lot of them actually, the predefined macros. There are a lot of them. So let's say I want to print the date now. So I will just use what, %s. This is also a string. So here I will pass in what, underscore date in caps, and then close it with another underscore. So the next thing is, assuming I want to print the line here, the current line in which my cursor is, right? I can simply say printf. Since I'm printing line, it's going to give you, or it's going to return the number, it's going to return the number of that line. Okay, so the number is definitely an integer, so I use %d /n, and I will call the macro, which is called what, line here, right? Line, and then close this. So now the macro that is responsible for printing the file name is called file. So I'll just call it printf. I'll just say %s /n, and then I'll pass in file. This is the macro that is responsible for printing the file name in which we are compiling from. So currently our file here is test.c, right? So I'm expecting this to print test.c. Okay, so now before we compile, let's check the number here. So as you can see, this line here, this particular code is on what, line 7. So I'm expecting this to print line 7 for me, and this I'm expecting this to print test.c. So let's see. Let's compile. Let's run it. So did you see that I got line 7 printed and I got test C printed? Okay, I'm just trying to show you some of the predefined macros that we have. Okay, so you can just use them, you can just call them and use them. You don't have to create them yourself. They have been created already. They are inside the stdio.h header file. Okay, all right, so let's move on to solve this particular problem here. So I'll open this. So vi to main.c here. So hash include, right? Include stdio.h. So don't forget your Betty. So this is main. I'll just say main function. I don't want to waste time writing all these things. I'm sure by now you're familiar with all these things. So return, just going to set it to 0. All right, so here I will just say int main, and then I'll pass in void, right? So inside this, inside the main function, I'll just use printf. I'll just say printf, and then I'll pass in %s, right? /n, and then I'll pass in what? Underscore file. That is what we are asked to do. We are asked to print the file name, right? The file name. So underscore, close, and then this. So here, I just simply need to return 0, right? So 0. So that's all. So let's run Betty on this. All right, so Betty is fine. So we can now compile the program. So copy, paste this. All right, so let's run the compiled file. So as you can see, we got 2 main.c. That's the file name in which we are compiling from, 2 main.c. So now let's try copying this, the content, right? We are trying to copy the content now to another file. So this CP here is copying the content of 2main.c towards 0 to main.c, right? We just want to test if it is going to print the new name of the file. So press enter. So let's compile with this new command here. So paste. So now we are compiling what, 0 to main.c, which is the file that contains the copy of 2 main.c, right? So press enter, compile. So let's run it. Oops, did I miss something? Okay, I think it's from my terminal here. Yeah, so as you can see, we got 02 main.c, right? So it has been compiled. It is printing what? The exact file name, isn't it? It is printing the exact file name. So it means this is working the way it's supposed to work. Okay, so don't forget to add, commit, and push to your GitHub, and then run your checks. So let's move on to the next task. So this task here says we should write a function like macro abs, which takes in an argument x that computes the absolute value of a number x. So this function here should compute the absolute value of x. So like I said to you that we can write functions using our preprocessor directive, and we are going to see how to do that now. Okay, so let me copy the file first. So this function here is supposed to find the absolute value of a number. And what is the absolute value of a number? It means the positive number, right? If -1 is passed, the absolute value of -1 is 1. So here I need to pass in if def, right? So what's the file name we created? Function like macro. So I will just say function like macro underscore h, right? So copy this. I don't want to type it again on the next line, so that's why #define, paste this. All right, so and if. All right, so here what I need to do first is say #define, right? So what's the macro name? abs, right? And it takes in what? An argument x. So how do we do this here? Firstly, we need to check if x is less than 0, right? So I need to open a bracket here, and I need to pass the value x here, right? X less than 0. So here I'm using what? The ternary operator. I'm going to use the ternary operator method to solve this problem here. So this is just saying if x is less than 0. If x is less than 0, what should happen? So I will pass in this question mark. So in this question mark here, this is just like if the condition is true, what do you want to execute? So I'll just say -x. If the condition is true, I'm multiplying the value of x with a minus sign. That will make it positive, right? So if x is less than 0, so multiply x with minus. So that means the minus will cancel out, right? Because initially, if it is less than 0, we know it is a negative number. So times minus here, the minus will cancel out. So we will be left with what? With the positive x, right? So this is just saying if x is less than 0, that is, if the condition is true now, this part will be executed. Else, if the condition is not true, this else is just saying if the condition is not true, then what should happen? So we pass in what? X here, right? If the condition is true, we just pass in x. So we don't need to multiply it with the minus sign because it is already positive, right? We don't need to multiply it with what? With any minus sign. Okay, so let me quickly explain this again. This is saying x less than 0, right? This is where you set the condition, and this is the ternary operator here, right? So the first argument after the question mark is if the condition you pass here is true, while the second argument after the full colon is if the condition is false. What should happen? Okay, so let's test this. Let me create my 3main.c file. So copy vi3main.c. So paste. Oops, not select all. So it is going to be paste. So here. All right, so let's compile this. Copy, paste. Yeah, so it has been compiled. So let's run the compiled file. So as you can see, we got 980, 980, 980, 980. Right? So this is what? Minus 98 is passed to the function. So it will multiply it with a minus sign. We've seen why, right? So it will become what? A positive 98. 98 times 10 is going to be 980. That's why you're having this first 980 here. And this is what? The positive 98 times 10 is what? Is still 980. Okay, so don't forget to add, commit, and push to a GitHub, and then you can run your checks. So let's move on to the next task. So this task here says we should write a function like macro, which is this, that computes the sum of the numbers x and y. It takes into argument x and y. So you need to write a function like macro that returns x plus y. Okay, it should just sum it. So let's see. Let's create the header file. So as you can see, all what we've been doing here, all the macros we're writing are inside the header file. So this is one of the use of the header files as well. So like I said, the use of header files is not just restricted to writing function prototypes. Okay, So what's the file name? File name is what? Sum.h, right? So I will just say sum underscore h. So hash define, this is going to be sum underscore h. So I need to fix this define. Yeah, so here I need to say hash and if. All right, so what I'm going to do here is hash define, right? So I'll pass in this, the function name, copy, and I'll paste it here. All right, so what do I need to do? I simply just need to open a bracket. Firstly, make sure that your return value, what you want your function to return, is inside a bracket. Don't leave it outside. If you leave it outside, it will still display the output correctly, but your checker will fail. Okay, so and then I will pass in the first argument, which is x, then I will add plus, and then open another bracket and pass in the second argument, which is y. This is what my function should return. So it's simply just saying x plus y. As you can see, x is in a separate bracket, y is also in a separate bracket, and all of them are enclosed within what bracket. So take note of this. If you leave them outside, the checker might fail. Okay, so let's try testing this. So let's create a test file. So vi for main.c, right? So let's paste this. So let's correct this. All right, so let's compile this and let's see the output. So compile, paste. Good, so it has been compiled. So let's run the compiled file. Yeah, so as you can see, we got 1122. This is simply 98 plus what? 1024. That's why we're having what? 1122. Okay, so these are just the different ways you can follow to create a macro and how to use them. Okay, so don't forget to add, commit, and push to your GitHub, and then you can run your checks. So we've solved all the project on this C preprocessor. So thank you very much. Till we meet in our next project.